Okay, we are going to start. So our question is saying we are given a scenario whereby we have two pellet guns, and this pellet gun A and pellet gun B. So both of the pellet guns have identical pellets, which means they are the same. Okay, and also both of the pellet guns, they are fired simultaneously, which means at the same time. There is no lagging in time with regard to firing of these guns. They are being fired at the same time from the edge of the cliff. So I just assumed by this line, which is dashed line, that is my cliff. Okay, that is my cliff. Okay, so initially the velocity for pellet gun A, it was fired at an initial velocity of 30 meters per second upwards. Okay, whereas for pellet gun B, it was fired downwards. That's why there's a negative here for the velocity, which is the direction. So it was fired downwards with the magnitude of the speed of 30 meters per second downwards. All right. So the velocity, it will be negative 30, assuming upwards as positive. Okay. So this is the height from the cliff to the ground. So the height from the cliff to the ground. So the cliff is where the position where the pellet gun was fired from. And also here it represents also the position on the cliff from where the pellet gun A was fired from until it returned back to the original level from where it was fired from. So what we know, if you fire that pellet gun here initially with 30 meters per second, when it returns, it will return back at the original position with the same velocity, but with the same magnitude of the velocity, but the direction is different. That is why there is a negative 30 and here it's a positive 30. It's because going upwards is positive, so it's positive 30 meters per second. As it goes down, it's negative, which is negative 30 meters per second. Now, this is our change in y, okay? And then this is the height from the cliff to the ground. The cliff to the ground, h meters, it's unknown. It was not given. Neither was the final velocity of ball B as it is the ground, it was not given. Nor the final velocity of ball A, of pellet A as it hits the ground, it was never given. So you can see from these two graphs, that this side of the graph from the initial level as it retained from the terminal velocity until it reaches the initial point. So from here to the ground, you can see the shape is also same with for pellet B from the cliff to the ground. Okay, so which implies that the same time taken from the cliff to the ground for pellet A is the same time taken for the pellet to reach the ground, pellet B, because the initial velocity for both pellets A and B as they move from the cliff to the ground is the same. So we are saying that the initial velocity for pellet A on the cliff is the same as the initial velocity for pellet B on the cliff, and the height from the cliff to the ground is also the same. Therefore, the same time will be taken along this path is equal to also to the same time taken along this path. The reason why B hits ground first is because of the lagging in pellet A. There is a time lagging here whereby pellet A had to go up and then come down, then it will start to go down. By that time in moment, already pellet B was moving downwards. So obviously you can see that pellet B is the one that is going to hit the ground first, but we don't know by how much time. So we are just going to calculate the lagging of the time only here. The time lagging, what is the time lagging? Then that will be our answer. So when the pellet A is fired upwards and returns to the original height, which is, this is the original height, it's fired, it returns to the original height, the change in Y is 0. Okay, the initial Y, then I come back, my final height is still 0, my initial height is 0, 0 minus 0 is 0. So the change in Y is 0, okay? We are going to use which formula now? So that we can be able to calculate what is happening. We want time, okay? So because we want to find time which was taken from that initial path, our final velocity, which final velocity are we referring to here? Not the one when it hits the ground, but we are referring to the final velocity, that one. So when I fire the pellet gun A, and then the pellet moves up and comes back, I want to know what is the final velocity here, not the final velocity here. That's why I had to use the change in Y as this one, which is above the ground. Okay, so remember, we are not using the change in Y, which is this one, but we are using from the cliff to the terminal velocity and to return to the original height. Okay, so Vf squared is equals to V initial plus 2g multiplied by change in Y, which is the same as saying Vf squared is equals to positive 30 meters per second plus 2 multiplied by the acceleration due to gravity along the path of going upwards. It's positive. The acceleration due to gravity, okay, and then which is 9.8 meters per second. You multiply it by 0, okay. If we multiply it by 0, what are we going to get? We are going to get 0, okay. And then we know that 330 squared is just 900 meters squared, second squared. Then square root of the answer, it will just give you the same thing which was inside the bracket. Okay, so, but this is the magnitude of the velocity. What is the velocity? The final velocity, remember these two quantities are scalar quantities, magnitude of velocity and speed. They are scalar quantities, speed and magnitude. Magnitude, it means size, and then speed, okay, and then speed, it will be a scalar, magnitude is the scalar. So we want to know what is the final velocity when it returns, when pellet A returns to the original height. So the final velocity is equals to negative. It's just the direction, which is in the negative direction, downwards. So that is the final velocity, or final velocity is equals to 30 meters per second downwards. Okay. So in the absence of air resistance, after how long after the pellet B hits the ground does pellet A hit the ground? That's what we want to calculate in the absence of air resistance. Okay, so the time delay is the one which we just calculated there, and then we found out the final velocity when the pellet A reached back to the original position. The final velocity was negative 30 meters per second. So now we are going to use that negative final velocity is equals to the initial plus g multiplied by t. So taking up as positive, okay, it has an implication of what g is sign is going to hold, whether positive or negative. All right. So already this formula, we have used it already, okay, to calculate the projectile until it returned to get Vf. So now we have to use another equation of motion, which is Vf is equals to Vi plus Gt. So now we are just plugging in our values. We have calculated already the Vf before. We found it that it was moving in the negative direction and the magnitude was 30 meters per second. So you put with the sign, negative 30. Sign is very important because the direction, it causes a lot of confusion and everything becomes wrong. So negative 30 meters per second, it has reached the original position, okay, is equals to Vi with what velocity was the pellet gun A fired. Pellet gun A was fired at 30 meters per second. Okay, if we choose upwards as positive, what is the acceleration due to gravity? Negative. It's very important, this one. It's a negative because it's opposing the motion. Because upwards is positive and acceleration due to gravity always want to force things down. So it has to be negative. It's opposing the motion upwards. That is why the pellet reaches terminal velocity, because of this acceleration, which is downward acceleration. So we simplify the equation. Negative 30 is equal to 30 minus positive and a negative times negative. It's a negative 9,8 meters per second multiplied by time. Alright, so we are multiplying by time. We are going to solve for time. So right, pushing this term to the left hand side, it becomes positive. 9,8t is equal to 30 plus 30, which is this 30. Negative 30 comes to the right, becomes positive. Dividing both the left hand side by 9,8, you also divide the right hand side by 9,8. So the total, the answer which you get there, the total time, the lagging, the time of the pellet when it was in flight, at the moment pellet B was being fired downwards, this was in flight for 6,1 seconds. So pellet A hits the ground 6,1 seconds after pellet B had already hit the ground. Okay, so obviously pellet B was the one to hit the ground, so this one was delayed because it had to go up and come down. Okay, So that is it. So for any questions, you are free to inbox me. Let's support one another, the tutorials. I'm available if you need any clarity or any corrections, we are here for you. Thank you.